Hello, everyone. Let's continue building our feature for sending the most liked ideas to our users. We've already written a cron job that is ready to send all this out. We have two tasks left. First, learn to fetch all the most liked ideas for this month. And second, learn to send them via mail. We already know how to send email messages, but we don't yet know how to send emails where the content is generated, for example, in loops. So we passed 5 ideas, and there are loops. But generating emails is the topic of the next lesson. In this lesson, we will learn how to fetch these most liked ideas, and we will write a custom query for Postgres. Well, let's get started with this gradually. How do we get a list of ideas like any of them? Well, we say select star. Star means all fields from the idea table. Here dbever suggests it automatically. We call and see a list of all our ideas. But this list doesn't have any information about likes. Okay, let's start by displaying not all fields, but only those we need for sending an email. To send the email, I believe we need the following contacts. We will need the ID column, so we replace the star with a comma-separated list of the things we need to know about the idea. The ID, well, we always take it as it's useful to have on hand. Then we need the idea's nickname to later form a link to it and send it in an email. We'll also need the title of this idea because, well, you need some kind of text, right, to show the person in the email, and this text will be the link. All right, and we'll need the number of likes. For now, let's just define it like this: 0 as month likes. So, and look, we make a request. In principle, we got the same data, but we managed to extract these 3 specifically from the idea, and we defined some fourth one manually here. Yes, that is, we indicated 0 and gave the name title this month likes count. That's why this column is named this way, and the value here is what we set for it. All right, the first step is done. Good. We know how to do this. Now let's try to find out the number of likes for a single specific idea. So, for now, we'll comment out this query and go look for the number of likes for a specific one. Let's see which idea has likes to search by. Here we have a super idea. It has 3 likes. Let's try counting them using Postgres. So, we take the ID of this super idea, copy it, and search. How do we determine the number of likes? Essentially, this is the number of records in the ID like table. Here's a reminder that we have a corresponding model in the Prisma schema. src, Prisma, schema. Here, ID like. So, how many ID like this ID has? That's how many likes it has. Let's write such a query. So, to start, let's just output select star from ID like. Call it. He added an L at the end here. He just created a short alias during the query. We don't need it yet, but we'll get to that soon. You can call it like this, and it will be the same. We got the list. There were a total of 7 likes in the system. All right? And for such ID ideas, let's display a list of likes only for our selected idea. For this, we subscribe. Where? So the field ID idea equals. And here, in single quotes, we insert the ID. And it works. What's important in Postgres? It's very important that in double quotes you write what is the name of the column, there, table, and so on. In single quotes, you write what is simply a string. If you write it like this, it won't work. And it will say, I don't see a column named ID-alike in the table with such a name. That's not how it works. Column does not exist. That's all. Don't confuse strings in single quotes with column names in double quotes. You can write without quotes, but only if your column names are all lowercase, which is not the case here. All right, so Great. We can see there are 3 rows here, but we want to know their count, not just see 3 rows. So, you can wrap this in the following structure. Count asterisk, and we get 3. That's what we wanted for one specific idea. Here it is. Now we need to combine our understanding and put this query inside here so it applies not just to the specified idea, but to every idea found here. Correct? Let's do it. So, now I'll comment out this request and uncomment that one. Okay? The most convenient way to do this is by using subselect. You can also use join, but subselect seems clearer. All right, so we need to replace 0 with the actual value. To replace 0 with the actual value, we open parentheses here and do absolutely whatever we want inside them. Got it, right? I just replaced 0 with parentheses, and now I will organize something here. Specifically, let's just insert our query here and see what happens. So you see our select was as it was. Here it remains completely intact. What happens in parentheses is something separate and will be substituted here. Let's call it there. So we see that all the lists come up, all the ideas, and each has 3 likes. Each has 3 likes because here in this month's likes count, we were exactly querying by this idea ID. But we need to query by the ID of this kind of idea. And basically, we could try to write it like this, but the question arises. Idea ID is taken well from the idea like table, but then both ID is taken, and we need idea ID from idea like and ID from idea. How to do this? You can do it just like this. Let's see what happens. Done. We have the current count of likes, but this structure is not very convenient. I recommend creating these shortened values. Just after the from line, you can add any line you want. This is idealike.l, and let idea be I. Done. You just renamed it. And now, you can do it like this, calling idealike.idea. Again, the same thing, but the record is shorter, making it easier for you to write queries. In principle, that's already great. But now we need to make sure that ideas with no likes don't end up here. Why report them at all? And it may seem to you that this good idea will work. Just specify that we need to take where this month likes count is greater than 0. That's it. Let's do this. Unfortunately, it won't work. We'll be told that this month likes count does not exist. Why doesn't it exist? We seemingly declared it here. The point is that in PostgreSQL, what's in where is processed before what's in select. Well, that's how it's designed. It only knows about the columns in the idea table, and such a column does not exist there. But that's absolutely not a problem, and it can be bypassed in the following way. There is a view construct in which we can place all our select, and then do a select on that very view. It sounds intimidating, but works simpler than it sounds. We just make a wrapper of the following type. We write with give a name in the select, which we want to somehow designate. We are now simply putting this select as if into a variable with, let's say, topids, and we say that topids as. And here we pass our select. That's it. Passed. Good. And now we can select from this. So treat this as if you set a variable topids here, which stores this select. Perform a select on it. Select asterisk. From, and simply from now topids. Select by it, where this month's likes count is greater than 0. Because it's now inside there. Run it, and that's it. We've filtered out all unnecessary ones, okay? What else do we need? Well, let's try an idea. We'll make 2 likes and work with sorts. Here's our liked idea, A. Well, let's go with this one. This idea, yes, got 2 likes. Requesting, so we have it sorted. Let's create one more user. Sign up. rightnow.com. And let's like some idea for them. See? 14. Good. It's better now. Yes. All done? Now it's not sorted. Let's play with sorting now. I suggest sorting right at this stage. Look. And how to add sorting. After from, we had from here. We need to do order by. We are sorting by the field this month likes count. And as we know, there's desk and there's ask. If desk, then in descending order. So big values first, then small. If ask, in ascending order. We need desk here. Okay? We added order by. Checking. Sorting succeeded. Also, we might have many ideas and want to send the top 10 ideas. So we need to limit our output. For this, you need to add a limit. Specify a number. Nothing changed because we still have 10 ideas here, right? But if I set, for example, 3, we would only get the first 3. At the same time, I set 10. But as we see, it's still 45. That is, well, no more than 10. Okay, let's leave the limit at 10. But right now, our query is actually searching for all ideas and all their likes for all time. But we only need the last month. For this, we need to add the corresponding filtering. And we will add the filtering right here in this select, where we search by ID like. We already have filtering by ID here, but we need to add filtering by creation date. Add where and after any condition, you can put end as many times as you want. Write end, then ID like, created at, should be more than a month ago. Any date later than a month ago. For this, there is a function now, which is the current time. From it, you can subtract any interval. Interval 1 month. This is how it is written. And then we will get the idea only with likes only made in the last month. All right? Given that we will call this function on the first days, it will work like that. Let's check. Well, since we did all this month, let's compare it with, say, a single day. Here. For today, I just gave these likes, so we can consider it working. And we also have a situation where some ideas are blocked and they got blocked. We'll not link to them because they can't be viewed. Therefore, we need to add another condition so that the idea itself is not blocked at. You can add the condition here if you want. Blocked at should be, well, from well. You can add it here. Let me block this super idea. Pity her, of course. Well, okay. So, block the idea. We're going around as admin, and we're starting to block, okay? Let's block idea Q. Here it is, idea Q. And I'm blocking it. Good. And idea Q disappeared from this list. There. But this isn't the most optimal way, because other ideas get into this selection. So you can easily add where here, well, the same thing, just move it there. Where and nothing should change. Yes. Everything works exactly the same. Add it wherever it's convenient for you. This affects performance. If you encounter a performance issue and have millions or billions of records, it's okay. We'll figure out how to optimize them. But admit, it's a nice problem to have millions of records and a challenge to search through them. That means you probably have thousands of users. Good. Okay, let's check if we've forgotten anything in this request. We take the ideas from the last month and sort them. Okay, looks like we've done everything. Here's the query written. Great. We wrote our custom query, but now we need to somehow call it from the code. That's it. We just copy this and go create a file. This file, I suggest putting it in the scripts folder because it's a piece of logic that is executed whenever needed. Let's call it notify about most liked ideas. This will be a function that searches for all ideas, then sends an email. But for now, let it just find them and display in the console. Let's break it down. Just a function that takes context as input because we'll use that context inside. As usual, ktx.prisma. Only before, we wrote something like .idea here and did something with it. But here, we say query raw. We say that we're going to call something raw here now. Then you can specify the type of what will be returned, which means what I defined here will be returned here. It's literally like I defined it through this construction. I'm saying there will be fields from idea, like pick fields ID, Nick, and name from idea. This object will also have the field this math likes count, and it will be a number. Okay, so let's take our query. Here it is. Here I have the end here, but it doesn't really matter. You can insert this query right here, and then, in this case, we'll just log these most liked IDs to the console. All right, now we need to add this function in cron in place of our console info. So, most liked ID. Now we need the context here, and just in case any error happens there, we'll catch it and log it to the console as an error. This record is the same as writing it like this. Error, console error, error. So it's the same thing. You don't have to do this, really, and it'll start complaining with the linter as well. In short, it's a long line. Well, you can leave it like that. It's actually more readable like that. But you can do it this way. It's more hacker-like. All right, now we need to call it somehow. So let's just check it now. To check that it works, we'll call it right when the server starts. But then we'll remove this line, of course. So here's our server. Here we save. Here we call. And here's our console info from here. So, the most liked ideas were found and displayed. Here they are. You may notice that I've got something here that we didn't have in the original code. ;int. This is typecasting in Postgres. By default, it's assumed that count possibly returns an int. And if I delete this int and save, you see, I get some unclear values here. Like 2n, 1n or something. What is that even? Right? Let this be a normal integer. There, I do it like this, and now I have a normal integer here. I can work with this, and everything is fine. Great! This is how you can call raw queries. Again, in a project, you will rarely need to write such custom queries. They make up about 1 to 2% of all the queries in your project. These queries are very easy to write using ChatGPT and Copilot. They give great suggestions. And basically, there's nothing particularly difficult in PostgreSQL queries. So, when you really need to write a query, you'll just handle it. If anything, seek help and advice. Great. Well, the custom SQL query is written and added to the cron function. All right, we'll remove this, and it will trigger at 10 huas on the first day of each month. Thank you all. We can proceed further.